Good evening, dear friends. Here is Earth Measured speaking, and I would like to speak to you in this evening about the analemma. The analemma probably you already know, because all people that study the flat Earth knows very well this strange shape. The analemma is this shape built by the sun during the year. You can make it by superposing many different pictures, one upon the other, of the sun taken every day at the same hour at the same place. For example, in this picture we have I think at least 2-3 pictures taken every month, maybe one for week. So we have in this point the Tropic of Capricorn on 21st of December, on this point the Tropic of Cancer on 21st of June. Somewhere here in the middle there is the equator, because this picture is not symmetrical and centered on the equator. We know that the sun makes this strange shape, and we know also, we have already seen that on a flat Earth the trajectory of the sun is a spiral on a cone, is a conical spiral, and in fact if you try to revolve this figure around a vertical axis, you obtain a cone with a very strange external shape that is given by this eighth shape of the analemma. But we would like to understand what is the cause of this analemma, and we have to understand the fact that we have a vortex of aether around the North Pole, and the proof is the Michelson-Gail experiment. You should make research about this experiment, because it is very important to prove the fact that light behaves in a different manner according to latitude. So it is important for every flat earther to know very well this experiment, the Michelson-Gail experiment done in 1925. So we have this vortex, and this vortex rotate with different speeds with the height to conserve the angular moment. Because due to the shape of the firmament, the largest part is in the higher part of the vortex, while going down we have smaller volume that have to go faster to conserve the moment. For example, if you think to a guy that is going to rollerblade, he is rotating around its proper axis, and if he has his arms along his body, he can rotate faster, while he can slow down his rotating speed if he open his arms. This is the conservation of angular moment. Okay, so if the sun moves a little higher, will move slower, while if it moves a little down, will accelerate. And in fact, we have here in this graph the analemma that shows that here we have the mean time of the day, 24 hours, and during the year, in this month, for example, here we have August, here we have October. During the year we have moments or months in which we have a faster sun, so the day is shorter than 24 hours, some minutes. For example, here we speak, okay, it is not easy to read, but we speak about some minutes. And also here we have a sun that is going slower, and we have a day that lasts a little more. This is linked to the equation time. You should study it if you want to understand the analemma. We have some day, it is a real equation, and this is the graph of the function in function of the time, January, February, March, and so on. Here we have the day that is lasting some minute less, some minute more, less, more. Here this is forming the little ring, while here is forming this part, and this one is forming the greater ring of the analemma. So if the sun moves a little higher on the vortex, and the sun has to move because it's trapped in a plane battle, magnetic battle, so it has a magnetic grid that or guide that guide it along its movement over the year, and so moving a little up will slow it down, and moving a little down will accelerate it. So we have an analemma that is tilted this way in the sky, and we can make a picture having a sort of section of this conical spiral of the sun that revolves around the North Pole axis. So we can explain very easily the shape of the analemma if we consider the fact that we have a vortex of aether moving around the North Pole axis, and considering the fact that it is rotating with different speeds over the aether. Okay, thank you very much because you have listened, you have watched also this video. Please subscribe to my channel. Bye bye, have a good weekend. Ciao.